Tonight on The Future of Everything, we've got 3i Atlas updates and maybe even our best shot yet to clearly see the third interstellar object.
NASA's latest announcement about the interstellar object 3i Atlas, making a close approach to Mars, has electrified both the scientific community and the public. This is not the first time humanity has tracked an interstellar visitor, but each instance carries profound weight, shaping how we understand the solar system's interactions with the wider galaxy. The fact that 3i Atlas is heading toward the red planet adds layers of intrigue, both because Mars itself is central to humanity's future exploration goals, and because of the rare opportunity this object presents for direct observation from multiple vantage points. The object is moving on a trajectory that cuts across our planetary neighborhood, and its approach to Mars positions scientists to observe a natural cosmic encounter unlike anything we have previously been able to study up close. Before we start, hit the like and subscribe buttons for more updates. 3. I-Atlas belongs to the small but extraordinary class of interstellar objects. These are bodies that did not originate in our solar system but were instead born around distant stars, or in the tumultuous environments of other stellar systems before being ejected into interstellar space. The first confirmed interstellar object was Oumuamua, discovered in 2017, followed by the interstellar comet 2I/Borisov in 2019. Each case stunned astronomers, not only because of the rarity of such sightings, but also because of the peculiarities these objects carried with them. Oumuamua's elongated shape and unusual acceleration sparked heated debates, while Borisov's composition revealed striking similarities to comets within our own solar system. Now, with 3i Atlas, the excitement resurfaces, particularly because its trajectory takes it closer to Mars than any interstellar object has come to a major planet while being actively tracked. The trajectory of 3i Atlas is no ordinary passage. Traveling at tremendous speed, it entered our solar system from a path that cannot be traced back to our sun. The very velocity of the object, greater than the solar escape velocity at vast distances, is evidence of its foreign origin. This alien wanderer, now bound only by a brief dance with our sun's gravity, will skim by Mars before continuing on its endless journey outward. The red planet thus becomes a stage for a fleeting but potentially transformative event, where the scientific instruments already stationed on and orbiting Mars might turn their attention skyward to glimpse the visitor. What makes this event especially compelling is the timing. Mars is currently orbited by a fleet of spacecraft from NASA, the European Space Agency, the United Arab Emirates, China, and India. On its surface, rovers like Perseverance and Curiosity, alongside landers, continue their daily observations. These assets, though primarily designed for planetary science, could provide unique perspectives on 3i Atlas. If the object passes within observational range, instruments might capture data on its shape, its spectrum, or even dust or gas emissions. This transforms Mars into a natural observatory, one that could give humanity its first close planetary-side look at a body from another star system. The scientific implications of such an observation are vast. Interstellar objects are messengers from environments far removed from our sun. They are relics, fragments of planetary systems that may resemble or differ greatly from our own. By studying their composition, scientists can test theories about how planets and comets form, both here and elsewhere in the galaxy. With 3i Atlas, the possibility arises of comparing Mars-based observations with those made from Earth, or even space-based telescopes orbiting our planet. This triangulated perspective could sharpen our models, yielding higher resolution insights than ever achieved before for an interstellar body. Another layer of intrigue comes from the philosophical and cultural impact of such discoveries. Each interstellar object challenges the boundaries of human imagination. For millennia, people wondered whether the stars above hosted worlds like our own. Now, material fragments from those distant systems are not just visible, but within reach of our instruments. It is one thing to speculate about exoplanets orbiting other stars, but to track a chunk of alien material as it sweeps past our planetary neighbor elevates the sense of connection to the galaxy at large. The passage of 3i Atlas past Mars underscores that our solar system is not isolated. It is part of a vast and dynamic network, constantly interacting, even if fleetingly, with the wider galactic environment. The name 3i Atlas itself carries significance. The I designates its status as an interstellar object, the third of its kind to be confirmed. Atlas, short for Asteroid Terrestrial Impact Last Alert System, is the survey project responsible for its discovery. Atlas, designed to detect small asteroids on Earth-bound trajectories, instead picked up this galactic traveler, emphasizing the dual role of planetary defense infrastructure. While protecting Earth, it also extends our awareness into the depths of space. This highlights the importance of continuous sky surveys. Without such systems, objects like 3I Atlas might pass unnoticed, depriving us of invaluable opportunities to study them. The physics of 3I Atlas's journey is another point of fascination. Interstellar objects move at speeds that dwarf those of typical comets and asteroids bound to our sun. Their hyperbolic trajectories ensure they enter and exit the solar system in a one-time-only passage. This means scientists have only a narrow window to capture as much data as possible before the visitor vanishes forever into the dark. For 3I Atlas, the approach to Mars provides a rare natural experiment. Observers on Earth face challenges from distance and perspective, but spacecraft near Mars could offer a front-row seat. Coordinating observations across millions of kilometers, involving instruments not originally intended for such targets, reflects the adaptability and ingenuity of modern planetary science. One of the key scientific pursuits in observing 3Y Atlas is spectroscopy, the analysis of light reflected or emitted by the object. By breaking down this light into its component wavelengths, scientists can identify chemical fingerprints. This can reveal whether the object contains water ice, carbon-based molecules, silicates, or other materials. The results could either reinforce the idea that planetary formation follows universal patterns, or conversely, highlight exotic differences that expand our models. For example, if 3I Atlas's spectrum matches that of common solar system comets, it would suggest that the basic ingredients of planets are similar across stellar nurseries. If not, then the diversity of planetary chemistry in the galaxy may be broader than anticipated. The cultural resonance of 3I Atlas's passage by Mars cannot be overstated. Humanity's fascination with Mars stretches back centuries, from ancient mythology to the telescopic visions of canals and the modern drive for robotic and crewed exploration. To see an interstellar object brush past this planet binds two profound threads of human curiosity: the exploration of our neighboring world and the search for our place in the cosmos. Mars, once thought to be a mysterious abode of life, now serves as a scientific outpost. Its role as an observational platform for interstellar matter deepens its significance in ways earlier generations could scarcely imagine. This event also reinvigorates discussions about the need for dedicated missions to intercept interstellar objects. The narrow windows of opportunity demand rapid response capabilities, something current space mission timelines struggle to accommodate. By the time an object like 3I Atlas is discovered, its trajectory and velocity often make it impossible to design, launch, and reach it in time for direct sampling. Yet with Mars hosting a constellation of orbiters and rovers, humanity finds itself in a better position than before to make opportunistic observations. Each successful measurement strengthens the case for building future missions designed with interstellar intercepts in mind. Even the trajectory of 3I Atlas through the solar system sparks imagination. Its hyperbolic arc tells a story of gravitational scattering long ago, perhaps from a giant planet in another stellar system flinging it into the abyss. For untold millions of years, it wandered the interstellar medium, buffeted by radiation and cosmic dust, before a chance alignment brought it within range of our telescopes. Its passage past Mars is not a message in any intentional sense, but it feels like one. A reminder of the galaxy's vastness and of the cosmic coincidences that connect us to it. Scientists are particularly interested in whether 3I Atlas exhibits comet-like activity as it nears the Sun. If sublimation of ices produces a visible coma or tail, it would become easier to analyze its composition, and it would provide a striking visual target for observers near Mars. If it remains inert, resembling a rocky asteroid, that too would offer critical information about the diversity of bodies ejected from other systems. Mars-based cameras could even detect faint outgassing that Earth-bound telescopes might miss. The discovery of subtle activity would reveal new insights into how these objects evolved during their interstellar journeys. If you liked this video, please give it a like and subscribe to our channel. Also, could you leave your comments below and tell us, what are your thoughts on 3I Atlas passing Mars soon? We want to hear from you. Thank you for watching, and see you next time.